Hello, we're going to have a run through of 91261, the NCEA Level 2 Mathematics and Statistics examination from this year, 2025. Apply algebraic methods in solving problems. So let's have a look at the questions. The first question is going to be a little bit controversial. And controversial basically in the first step. So to simplify this, you need to take the square root of the y to the power of 6 over 64 term under the square root sign there. So we get this is equal to 5y. The square root of 64 is no problem. That's going to be over 8. The square root of y to the power of 6 is a problem. The standard procedure is just to halve the exponent and get y cubed. And yeah, this is problematic. We'll come back to it. Y multiplied by y cubed is y fourth, so you end up with 5y to the power of 4 divided by 8. And it should be, well, I think the question's designed to be that simple. The problem is, it's commonly assumed that if I take the square root of x squared, you get x, but that's not true. It is true only when x is bigger than or equal to 0. When x is less than 0, the square root of x squared is negative x. And that looks odd to some people, looks counterintuitive, but it's what happens. So if we just look, say x is negative 1, we've now got the square root of negative 1 squared. Negative 1 squared is 1. It's the square root of 1, and that's 1. And that clearly is not equal to minus 1. 1 is equal to the negative of minus 1. So now this problem, a problem of this type, turned up in last year's algebra examination, level 2 algebra examination. The question was to simplify this beast, and the solution was to factorize the top line, and it factorizes to 3x plus 5 squared, and factorize the bottom line. It's got a factor of x, and then we'll have 5 plus 3x, which is the same as 3x plus 5. And then in the solutions from here, they just there's a square root sign around here. In the solutions from here, on the top line, they wrote 3x plus 5 over x times 5 plus 3x. Cancelled these and got 1 over x. I've actually got the I've got the assessment schedule from last year's examination. You can see that's exactly what they did. But in fact, this bit here, this equality is only equal when 3x plus 5 is bigger than or equal to 0. You get negative 3x plus 5, negative 3x minus 5 over x, 3x plus 5, when x is less than 0. And then in this case, if you cancel that, you'll get a minus 1 here, so you get minus 1 over x for, I wrote x less than 0. 3x plus 5 less than 0, which is, put the 5 over here, it's minus 5, so it's x less than negative 5 over 3. I did correspond with the NZQA people, and they seem to have just ignored the problem. I suspect they're going to do the same this year and say this is the correct answer, but this is really only true for x, for y bigger than or equal to 0. Yeah, if y is negative, basically any even power, if y is less than 0, then y to the power of 6, any even power, is always going to be greater than 0. And then when you take the square root, you need a positive number, but y cubed is less than 0 because we've got a negative to multiply by itself 3 times. So you really do need to put, really do need to be correct to have the negative of that for when y is less than 0. So you need both of these parts to have a correct solution, but I suspect that they're not going to do that in the examination marking. But it really is a poor practice. These are the sort of things you can see memes on the internet that prove that 0 equals 1. They use hidden fallacies like this to make those proofs. Anyway, let's move on. Rearrange to make x the subject. So if you cube everything, it gets rid of a cube root. So it's 2y cubed, I prefer my pink pen, 2y all cubed is going to be equal to 7x minus 5. Add the 5 on the other side. I'm going to multiply this bracket out. 2 cubed is 8. Y cubed plus 5 equals 7x. Swap it over. X is equal to 8y cubed plus 5, all divided by 7. No controversy, that's good. Consider the graph of y equals 2x squared plus ax plus b, where a and b are constants. One of the points where the graph crosses the x-axis is at 1.50. The point minus 1, minus 5 also lies on the graph. Find the values of a and b. I think one way to do this anyway is to put, these are the x and y coordinates that satisfy this equation. So if you put y, which is 0, is equal to 2 times 1.5 squared plus a times 1.5 plus b. We can tidy that up. 1.5 squared is 2.25, so 2 lots of that is 4.5, so 0 equals 4.5 plus 1.5a plus b. You could double this if you wanted and get rid of these decimals. And if we do the same for the other point, that tells us negative 5, that's the y value there, is equal to 2 times negative 1 squared plus a times negative 1 plus b. So that's negative 5 is equal to negative 1 squared is 1, that's 2 plus minus a plus b. I can tidy this up, put the negative 5 on the other side, and we'll get 2 equations. So this equation and this equation that have got 0 on this side, and we want to solve these. We've got 2 equations, 2 unknowns. It's a simultaneous equation. Simultaneous equations, we will find b. So if we just do, say, equation 1, take off equation 2. So on the left, we've got 0 minus 0. 4.5 take away 7, that's negative 2.5. 1.5 take away -1, that's going to be 2.5. And b take away b, we've eliminated the b's. Put the 2.5 on the other side and divide by 2.5. You can see, I think, quite easily that a has to be 1. Minus 2.5 plus 2.5 will be 0 when a is 1, so that's good. And then to find b, we just have to substitute in one of these equations. So this one's got no decimal, so I'll use that. So we get equation in 2, we get -7 minus 1 plus b has to be 0. That's 6 plus b has to be 0, so b will be -6. And we've found a and b. Part D, a rectangle is inscribed in a circle with radius r, as shown in the diagram. The length of the rectangle, so the length here, call this the length, is twice the width. Call this the width. Find a fully simplified expression for the area of the rectangle in terms of r. I think it's easiest to work with just one of these little rectangles. And obviously the length is going to be twice the length of that little rectangle, and the width is going to be twice the length of this little rectangle. So I'm going to draw a bigger version of the little rectangle with the diagonal r, and I'm just going to call the sides a and b, and we know that b is twice a. Now we can use Pythagoras. And we will get a squared plus b squared, which is 2a squared. It has to be equal to r squared. This is 4a squared plus an a squared, that's 5a squared equals r squared. So r squared is going to be equal to, well, no, that's what r squared is. A squared is going to be more useful to us. A squared is going to be equal to r squared divided by 5. If we want the area of the rectangle, well, our length is 2 lots of b, 2 lots of 2a, so it's 4a, multiplied by our width, which is 2 lots of a, is 8a squared, and we know what a squared is. So it's 8r squared over 5, and now we've got the area. Find a fully simplified expression for the area of the rectangle in terms of r. So we're done. Solve 5 to the power of 2x plus 1 minus 120 equals 5 to the power of x plus 2, and let n equals 5 to the power of x is a hint. So we can see pretty quickly that this is going to be a quadratic. Some people call these quadratics in disguise. So, and the reason is that 5 to the power of 2x is the same as 5 to the power of x squared. And a hint is saying call this n. So we've got a 5 to the power of 2x here, and we've got a 5 to the power of x here. So it's got an n squared here and an n here. What do we do with the plus 1 and the plus 2? Well, that's an application of if you have a power. So if you have x to the power of a plus b, that's the same as x to the power of a times x to the power of b. So the +1 and the +2 we can take off as separate powers. So let's go about that. This is 5 to the power of 2x times 5 to the power of 1 minus 120, and I'm going to shift this on the other side, minus 5 to the power of x times 5 to the power of 2, and that's equal to 0. This 5 can go in front, so it's 5 times 5 to the power of x squared minus, I'll write this term next, that'll get our quadratic into nearly standard form. 5 squared is the constant in front, 5 squared times 5 to the power of x minus 120 equals 0. I think I will cancel the 5, so divide through by 5. You lose this one becomes 5. 5s into 12 is twice. 2 over 5s into 20 is 4. So now we have, and if we put n equal to 5 to the power of x, we get n squared minus 5n minus 24 equals 0. Multiply to 24, negative 24, add to minus 5, that's 8, negative 8, and positive 3. So n equals 8, or n equals negative 3. But remember, n is 5 to the power of x equals 8, or 5 to the power of x equals negative 3. This one's not possible. Exponential, any exponential, well, yeah, it's, since it's for learning purposes, any exponential. So if you have any number to the power of x, this is always greater than 0. Well, let's say provided a is bigger than 0. Exponential graphs look like this. They have an asymptote down here. So you can't get, there's no number x that will make 5 to the power of x equal to negative 3. And this one here we solve by logarithms. Logarithm of 5 to the power of x is equal to the logarithm of 8. The x can go out the front. X log 5 is equal to log 8, and therefore x is equal to log 8 divided by log 5. You can do that on your calculator and get an answer. I'm going to just leave it there like that. When you use your calculator, you can use any logarithm as long as you're consistent. So on the calculator, there's two buttons. There's a log button and there's a ln button. This one is log base 10, and this one is log base e. But as long as you use the same logarithm button, you'll get exactly the same answer. It's good little exercise for you to experiment at least once. So do this calculation with both buttons and see that you get exactly the same answer. So yeah, we're done. If you want to get a number. Question 2. That was 1e, was it? Yep. Question 2. What is the value of k needed to write 9x squared minus 30x plus k as a perfect square? If we're done last year's examination, this is the perfect square. It's factorized, so it's 25 is what we're going to expect. So 2 years in a row they've used the same quadratic but in a different way. So to write this as a perfect square, we basically need, well, there's multiple ways you could do this. We need a linear term like this squared, which is going to be a squared x squared plus 2abx plus b squared, and we need that to be 9x squared plus minus, what did they have plus last year, minus 30x plus b squared plus k. So from here, from these two here, we've got that b squared is equal to k. So if we find b, we take the square root. From the first one, we get 9 has to be a squared. Might have been better to write that the other way around. Therefore, a is equal to 3. You could actually get plus or minus 3 here. We'll explore that in a minute. Now, once we've got a is 3, now we've got, for this second coefficient, we've got 2ab has to equal minus 30. So divide by 2 and divide by 3. So divide 2 3s are 6. So this is, well, it's write it in 2 times 3b equals minus 30. Divide by 6, b is equal to minus 5. And as we said, k, therefore, now we've found b, k is equal to b squared, which is negative 5, squared, which is 25. And that's our final answer. If you put minus 3 in here, so if you put in plus or minus here, so then you get plus or minus in here, and then you'll get minus or plus here, minus or plus, but when you square them, you still get 25. So both of these solutions for A give us the same value for K. K is B squared. It doesn't matter whether B is the positive or negative version of itself. Question B. Simplify fully. In practice, what this means is factorize both the top and the bottom, numerator and denominator, and cancel common factors. So immediately we can see in the numerator there's a factor of x, so I'm going to take that out. But there's also a factor of 2 in the numerator. I'm going to take that out. 2x times 3x squared gives me 6x cubed. 2x times 13x gives me 26x squared. And 2x times minus 10 gives me minus 20x. And divide that by 5x squared plus 23x minus 10. Now you use your favorite method to factorize a quadratic. I guess you can put it into a calculator and find the solutions. 3 times minus 10 is 30, negative 30, so we want two numbers that multiply to give this and add to give 13. Now that's quite easy. It's plus 15 and minus 2. So now let's just do separate working. So 3x squared plus 15x minus 2x minus 10. That's going to be common factor of 3x, x plus 5, common factor of minus 2, x plus 5. So 3x, no bracket yet, minus 2 times x plus 5. That's the numerator. In the denominator, we do a similar thing. We want numbers that multiply to negative 50 and add to 23. And that's a similar factorization, really. It's 25 times 2. So minus 25. No, 23. Yeah, plus 25. And minus 2. 5x is common. It's times x plus 5 minus 2. It's very similar. So we get 5x minus 2 and x plus 5. And then we see these two terms are common, so we can cancel those out. And there are no other common factors, so we cannot simplify any. Whoops, don't really want to do that. I'll do it again. Improve your motor skills. So this is our solution. The solutions to the equation 10 over 3x minus 1 all squared equals 2 can be written in the form 1 plus root a over b and 1 minus root a over b. Find the values of a and b. Okay. If we just cross multiply the algebraic squared term up here and divide by the 2, we will get an equation that says 5 is equal to 3x minus 1 all squared. We can solve that by taking the square root, so we get plus or minus the square root of 5 is equal to 3x minus 1. We can add the 1, so we get 1 plus or minus root 5 is equal to 3x, and we can divide by the 3. 1 plus or minus root 5 over 3 is equal to x. That's not quite our solution. That's two things in this form. It says find the values of a and b, so a is equal to 5 and b is equal to 3. So this is really our solution here. Part D, solve the logarithmic equation, log base 5 x plus 6 multiplied by 2, take away log base 5 of x, subtract 2 equals 0. I'm going to put all of the log terms on one side and put the 2 on the other side. And we're going to be using these facts here. If you have b log a, that's the same as log a to the power of b. And if you have log a minus log b, that's the same as log a divided by b. So subtraction outside can be converted to a division inside. There's another one with a positive plus here and you get multiplication, but we're not going to need to use that in this particular question. So let's write it down. For completeness, these are three of the log rules that we use over and over again. So we've got a 2 outside, so that's going to become a squared inside. Let's go slowly. And as I said, I'm going to put the 2 on the other side. Now we've got a subtraction, so that becomes a division. Log base 5 x plus 6 squared divided by x equals 2. Now I remember from when I was at school in order to get these changed, you can change a logarithm statement like this into a power statement. And the way I remember to do that is I remember this fact here, log base 10 of 100, you can do that on your calculator if you want, is equal to 2. And that's equivalent to the power statement, 10 squared equals 100. 10 squared equals 100, we all know easily, and this is just one logarithm statement to remember. When you're doing log base 10 and you've got a power of 10 here, basically the logarithm is how many zeros you've got. So that's an easy one to remember. And that reminds me, I used to write this down in my examination. That reminds me, I take this power, I take this base, it becomes the base over here. The answer on the other side becomes the power, and the argument of the logarithm becomes the right-hand side. So you might choose to remember that some other way, but so we get 5 squared is equal to x plus 6 squared over x. 5 squared is 25. I can multiply through by x, so I get 25x, and I can multiply out this bracket x squared plus 12x plus 36, 6x. There's 2 of these terms. Take off the 25, so I'm going to get x squared minus 13x plus 36 equals 0. That factorizes 9 fours are 36, and 9 and 4 is 13. It's got a minus sign to get negative 13 equals 0, so we have x equals 4, or x equals 9. And I think we're done. Solve that equation. So there's 2 solutions. The values of x and y satisfy the simultaneous equations where k is a non-zero constant. Given that there is only one solution to the equations, find the value of k. Okay, so we've got second equation here involves a y. We could use a substitution from the first one. So if we rewrite that first equation as y equal to 2x plus 13, and then substitute that into the second equation for y here. So you'd get x squared plus 2k, y has become 2x plus 13, equals 6k. I'll shift that onto the other side to make it equal 0, because we've got a familiar quadratic here, and we want to get it into standard form before we do anything with it. So it's x squared, 2 2s are 4, k times x, so plus 4kx, and then plus 2 13s are 26k, minus 6k equal to 0, so x squared plus 4kx plus 20k equals 0. This is a quadratic. Quadratics typically have 2 solutions. They can have none and one, but we're told in the question that there is only one solution. So we want the case where there's one solution. That means that the discriminant, which is b squared, 4k all squared, minus 4 times a, which is 1, times c, which is 20k, we want that to be 0. I can see straight away that there's 4 squared is going to be a common factor. That's 16, because I've got a 4 here, and 4 also divides into 20. And k is a common factor because there's k squared here and there's k here, so I can take that common factor out. I'm going to be left with 1k here. Over here, I'm just going to be left with 5. I've taken 4 out. I've taken 4 out of here, so this is 4 times 5. I've taken the k out, equal to 0. That means k is equal to 0, or k is equal to 5. The question says k is non-zero. so we can't have the k equal to 0, so therefore k is equal to 5. That's found the value of k, but we also needed to solve the simultaneous equations, find the solution of these simultaneous equations. So we've got k equal to 5. If we put that into our quadratic says x squared plus 4 times 5 is 20. X 20 times 5 is 100 equals 0. That's the same as x plus 10 all squared equals 0. That's the same as x equal to negative 10. And if x is negative 10, up here we've got y is equal to 2 times negative 10 plus 13 minus 20 plus 13, that's minus 7. So this is the solution of our simultaneous equations. Solution of these simultaneous equations when there is precisely one solution. On to question 3. Solve the logarithm of base root x of 8 is equal to 6. As I said before, I remember this one here that tells me 10 squared equals 100, and that just tells me where to put all of these terms. So I can change this into a power. Root x is the base, 6 is the power, and it has to equal 8. If I square root x, I get x. So root x squared to the power of 3. Squared will get rid of the square root. 2 times 3 is 6, so I can break that up. Power of a power you multiply, so this is the same as x cubed equals 8. You could do that with logarithms, but this is such a common one that you probably should remember that if x is 2 cubed, 8 is 2 cubed. Comes up quite often. If you used logarithms, you could go log x cubed equals log 8. 3 log x equals log 8. Log x equals log 8 over 3. Yeah, much longer. So now to get x, you have to raise this. You do this calculation, you'll get something and raise it to the power of 10. So if I go 10 to the power of log x, that's going to be 10 to the power of all of this. Doesn't come out nicely, but this is x, and you'll get this calculation here will be will hopefully give you 2. Pretty sure it will. A quadratic equation ax squared plus bx plus c equals 0 has solutions of 1 over 5 and negative 2 over 3. Find the values of the integers a, b, and c. This is a second question that I think is a little bit problematic, and the problematic part is this word the here, because there is not just one quadratic equation of this form that satisfies the conditions here. In fact, if we go back, you'll notice here that effectively by telling us these solutions, they've given us 2 points. So we've got a quadratic. We don't know which way up it is, but make this 1/5 and somewhere along here minus 2/3. Don't know if that's good enough. 2/5. Maybe I'm not quite. So all we know is that the quadratic goes through these 2 points. We don't even know whether it's upside down or right side up. We do know that we've got these 2 points that this quadratic goes through. And if you know 2 points, that's 2 bits of information. You can solve for 2 variables, but not 3. So there's freedom in selecting a third variable, and well, that might actually affect what the other 2 are. But if we compare with a question that's already in this examination at an earlier stage, this question here, which is 1C, here they give us 2 points, but we only have to solve for A and B. We end up with 2 equations, 2 unknowns, and that's a doable problem. This one that we're doing now, we've got effectively 2 equations. We've got 2 equations based on these 2 points, but 3 unknowns. So if you tried to do this the same way, for example, if we said, so x is 1/5, a times 1/5 squared plus b times 1/5 plus c equals 0, and now we can multiply that out, so that's 1/25. 1/25 a plus 1/5 b plus c equals 0. Perhaps multiply through by 25 to get rid of the nasty fractions, so you get a plus 5b plus 25c equals 0. And then that's one equation. And then if we put in minus 2/3, we'd get a times minus 2/3 squared plus b times minus 2/3 plus c equals 0. Square this, so you get 4 over 9. 4a over 9 minus 2b over 3 plus c equals 0. And we can multiply through by 9, so we get 4a minus 6b plus 9c equals 0. We've got equation 2. And all we've got is 2 equations with 2 unknowns, 3 unknowns. And you can't typically solve that. For unique values of A, B, and C. There's a little bit of extra information. It says the solutions have to be integers. So any solution of these 2 equations where A, B, and C weren't all integers would be flawed, be excluded. But nevertheless, as I'll show you in a moment, there's still more than one integer solution that satisfies this question, and in fact there's an infinite number of integer solutions that satisfy this question. And the question, though, suggests to us that there's only one solution. Find the values. The is a definite article. This is a maths exam, but I'm teaching English here. The values suggests that there's only one solution. But anyway, let's have another look at it. Let's have a look at a different way to solve this. You could go about doing these simultaneous equations. We don't normally teach equations in 3 variables, or certainly not solving equations with 2 equations with 3 variables. In more advanced mathematics, you'll learn that if you've got that case, then one of the variables is free, so you're free to choose one value, and then you can solve for the other 2. and that's because you're free to choose one variable. There's basically an infinite number of solutions. So yeah. Anyway, so let's look at a different way to try and get a solution, not the solution. I don't think this is just being nitpicky. I think it's poor wording. Students might think that they need to get one particular solution when that's not the case, and so they may start scratching their heads as to what am I missing here. As soon as they realise they've got two different solutions, which one of these could be right? Anyway, we've got a solution 1 over 5 and a solution negative 2 over 3. So when x equals 1 over 5 is a solution, now that means x minus 1 over 5 is a factor. Actually, we can, if you multiply through by 5, you could rewrite this factor as 5x minus 1. And a way to do that is actually to work with this equation here. If we, well, yeah, this is an equation, so it will deliver 5x minus 1 equals 0. If we multiply by 5, we get 5x equals 1. 5x minus 1 equals 0. And that's what you get for a solution. If you do the same thing when x equals minus 2/3, that will lead to 3x equals minus 2, which leads to 3x plus 2 equals 0. And now if we take these two linear terms and multiply them together, so we have to multiply out 15x squared plus 10x minus 3x minus 2. So 15x squared plus 7x minus 2. Yeah, that's a quadratic that has those two values as a solution. So we've got a equals 15, b equals 7, and c equals minus 2. This might be the most natural solution you'll get, but as I said previously, we don't even know at this point whether the quadratic is upright or inverted, and so what that means is we could just negate all of these. So a equals minus 15, b equals minus 7, and c equals 2 would also be a solution. But as I said, you can get an infinite number. If you multiply this by 2, a equals 30, b equals 14, c equals minus 4 would be a solution as well. And you can multiply by any integer basically, and you'll get an integer solution. So I think the wording should be more careful in these questions, and there are past NCEA exams where they have been careful and said find a solution, but effectively giving us 2 points and asking us to find 3 unknowns is not enough information, and the fact that they have to be integers doesn't overcome that. So anyway, that's my take on the question. If P equals log A of 3 and Q equals log A of 5, write log A of 75 in terms of P and Q. Well, this is basically a factorization of 75. So log A of 75 is the same as log A of 3 times 25. which is the same as log A of 3 plus log A of 25, which is the same as log A of 3 plus log A of 5 squared. I didn't quite have enough room to write it all out on one line. We can take the power outside the logarithm, 2 times the logarithm base A of 5. You might not need to do all that working. In fact, I think I can see straight away this is 3 times 25, so I could probably write down straight away log A of 3 plus log A of 25 is 5 squared and put that out like this. So you might be able to go directly from here to here. You might need some, but not all of these lines are working. Log A of 3, that's P, and log A of 5 is Q, 2Q. And there's our solution. An expression for the sum of two squares can be written as a squared plus b squared equals a plus b all squared minus 2ab. It's not required, but it's interesting to see how you get that. So if you have a plus b squared, you know that that's a squared plus 2ab plus b squared. So therefore, just rearranging this, a squared plus b squared from the right-hand side is going to be equal to this left-hand side, and minus this term. We're shifting that over to the other side. So it's a straightforward equation that you would be able to derive for yourself. So we've got that equation, and it says if A and B are solutions of this equation, find an expression for a squared plus b squared in terms of m and n. So if A and B are solutions, then x minus a and x, we'll say one thing, write something else down, x minus b are factors. And if I multiply that out, I have to get the quadratic. Indeed, the question 2 questions ago, we've got 2 solutions and we've got 3 unknowns. This question is of a similar sort, but we've got 2 solutions and we've only got 2 unknowns. They've done that by fixing the coefficient of x squared as 1. And that's what I said. We've got one of the variables a, b, and c are free in that previous one. So we can fix, if we fix that, then we can find a unique solution for the others. But yeah. So the examiners implicitly know that if they give you 2 bits of information, you can only do something about 2 variables. But they didn't apply that on the previous question. If we multiply this out, we get x squared minus bx minus ax, so that's minus a plus bx minus a minus b, and then plus ab is equal to x squared minus mx plus n. Therefore, this a plus b has to equal this m, and this a times b has to equal this n. And they want us to find an expression for a squared plus b squared in terms of m and n. And they told us that a squared plus b squared is a plus b squared and minus 2ab. Well, a plus b is given here, and a b is given here. So this is going to be equal to a plus b is m squared minus 2n. And our final question. Shiloh is about to play a golf hole. She starts T at point A, and as shown in the diagram, normally golfers take the route A, B, B, C to get to the end of the whole flag. I used to play a lot of golf, and most of my golf and most of the golf of the people I played against, they didn't hit the ball in straight lines like that. But that's a side story. However, there's a tree in the way that she will need to clear. So she decides to take a risk and go direct from the start tee to the end flag. However, there's a tree in the way that she needs to clear. The start tee is 2 meters above the ground. It's shown here. And the ball reaches its maximum height of 20 meters when it is 110 meters from the start. That's 20 meters above the flag, not the tee, and 110 meters from the start. So we've got 110 meters here. The tree is 7.5 meters high. To do these problems, you need, and it's 200 meters from here. So to do these problems, you need to set up some coordinates, and as long as you're consistent, it doesn't really matter where you set them up. In fact, I think I'm going to try and do this question in 2 different ways and show that you can effectively get the correct answer both ways. So let's, I'm just going to redraw the picture a little bit bigger. So we've got a parabola. And I'm going to set my coordinates like this. So this is the midpoint. This is the T box. So this is at minus 110. We've got, this is the flag down here. This is minus 2. This distance is 18, so that means we're up to 18 up here. And we've got a tree that's 200 from here, so that's 110. It's another 90. At 90, we've got a tree that goes up, and the tree is 5.5 because there's 2 down to the ground level. Okay, and what we want to find out, we want to construct a parabolic equation that meets all of these criteria, or meets this criteria that it goes from negative 110 to 110, and has a maximum at 18. So again, there's more than one way to do this model, but one model for that is y equals a x squared and then plus 18. So we've got a basic parabola which usually goes through the origin. If you put some coefficient in front of it, that's just stretching or compressing it, but our one has to go up to 18 for its y-intercept. We're expecting a to be negative here to get the inverted parabola, but that's basically our model with these coordinates. And we know at x equals negative 110, y equals 0. So that will enable us to find out the value of a. So we get 0 is equal to a times negative 110 squared plus 18. That means a times this equals negative 18, and negative 18, and then we divide by this squared. So 11s are 121 with 2 zeros on the end. Now you can get a decimal value if you want, but it is negative as we expect, and this will be an equation for our parabola. So our model has become y equals minus 18 over 12100 x squared plus 18. And we want to know the y height when x is 90. Y evaluated at 90 is negative 18 over 12100 times 90 squared plus 18. That looks like calculator work. Negative 18 over 12100 times 90 squared equals negative 18 over 12100 times 90 squared plus 18. I get 5.95 meters. And what I'm interested in is that that's greater than 5.5. Therefore, Shiloh will or can clear the tree. Yep, so the ball will be high enough if it follows this parabolic path. As I said, let's try and do the question with a different set of coordinates. It's actually not that obvious what to do. The only other alternative you could do is put the x-axis down the bottom here, really, because then you have a problem if you put this x-axis down the bottom. Then we don't have the intercept here. I guess we could make it. I guess you could put a x and y coordinate like that. Let's have a go at that and just see how we get on. The algebra will be different, but you'll still be able to solve the problem. So let's redraw the picture. We're up here at 2 meters. We've got a parabola that goes. It's got its apex there at 1110. Its height is 20, and out here at 200. We've got a tree that's 7.5. And obviously my picture's not to scale, but that picture has got the relevant information on. So let's have a look at what we could do for that. Well, the tree's 7.5. The tree doesn't actually have to hit. The tree goes to 7.5. We know because of our previous calculation that it's below the parabola, but we don't actually know. We don't actually know that. Can we get a model for this? Yeah, it's harder to write the. Oh well, we've got 2 points. What did we use before? We used the fact that it was just that the parabola was centered at the origin. So that used that point. Yeah, we're centered at x minus. Well, I think you'd have to write the model here as y equals a times x minus 110. Yeah, plus 18. It's just shifting that whole model across. Well, actually, it's not 18 now, it's 20. I think you'd have to write the model like this. And I think it's going to work out pretty. And again, we have to use this point here to find a. So this point here is 2. So y is 2 when x is 0. So a times, this is squared, minus 110 squared plus 20. And you can see if you make up this model, it's going to turn out the same, because when I take off 20, I get a times minus 110 squared equals minus 18, and that's the same as before. So you can see if you set the problem up differently, that you can and will get the same solution as long as you do the correct algebra, and from there it's going to be equivalent. That this won't will fly over the tree, because we end up putting 200 in here. We take 200, take away 110, we get 90 in there. It's going to be the same calculation. So other questions, it might be easier to get two completely different sorts of solutions, but usually if that's the case, you know the two roots. We could get the roots here by making, this is 110 and this will be 220 because it's symmetric. But yeah, so there are other ways to do the model, and they could work as well. But yeah. Anyway, any questions? We'll stop here. Any questions? Just put them in the comments and see how you go with that. Thank you very much for watching.